So topic what I've taken today is about the linear regression using TensorFlow. So the topic is not something very new it is, but I just want to throw a light on this, what exactly the regression techniques, because most of them are doing with the machine learning, deep learning, and most of the concepts, advanced concepts in that. But what is the logic behind that? What exactly happening in that? Most of them, in the point of a student point of view in my college, so they were not aware of that. So this motivates me that go inside to this topic, and I've been research on this project. Means the linear regression itself with a different of the TensorFlow, PyTorch, and all different IBM Watson. So all different API had been used. So I'm throwing a light on the TensorFlow, and even I want to know about like what advances from your suggestions also. So let's go to the difference between like what is machine learning and the classical programming, the programming backgrounds, and for computer science students or the faculty, it would be the very simple thing. So as we can see in the classical programmings, we have a different set of rules and data, the variables we used to give, and we have an answer for that as an output. When it comes to the machine learning, the most important thing is that we have a data, and of course, we know that what is an answer. Then accordingly, the output what I'm going to get is about the rules. So from the rules, like we are going to do the all the backward propagations, what are the things accordingly, because we know already the answer. So accordingly, we are going to adjust our rules with respect to my inputs. So that is the difference between the machine learning and the classical programming. So this is just an overview because for the linear regressions, it's a part of the algorithms in machine learning. So I just want to throw the light on this classical programming, the difference between classical programming and machine learning. So the topic is regressions. Like we have a different types of regressions are there, under which I'll be explaining about the linear regressions. So regression is about like study of the two variables. So the two variable may be the dependent variable and independent variable in numerical methods. So the first of all, like if the dependent variable is numerical, then independent variable is categorical. So, and if we go for any machine learning model, the most important thing we need to identify is that which is a dependent variable and independent variable. So based on this, we are going to make that like which are the targets and what are our inputs. And the most important task without having a knowledge of that particular company, if they are working and all, they need to identify about like which kind of the data is a numerical and that is about your dependent variable and independent variable. That is the most important task in this. So let's go and see that for an example, like what are the different types of this. So then I'll be explaining with the collab, like how exactly the linear regression works, but just as a theoretical point of view, I just want to show you that. Suppose if I want to testing an IQ, like what IQs are, that is your like effects and income. So IQ is an independent variable, the income is our dependent variable. Similarly, in case of the testing work of hours, how many hours of affects the sleep. So dependent variable is the hours of sleep and hours of work is an independent variable. So how much type of you're working, that would be the independent. Dependent variable would be the hours of sleep. So the both are related. So this is a few examples to show you that like which is dependent and independent variable. In case of the number of cigarettes smoked to affects the blood pressures, the number of cigarettes smoked by a person, so that would be the independent variable and blood pressure would be the dependent variable. So the blood pressure is depends upon the number of cigarettes they smoked, but which is not under the control of this. So that is the person. So that would be the independent variable. So by seeing this, we can see this, which would be the target and which would be my inputs. So when you have the data sets, the most important thing we need to find out here is what are my dependent and independent variable. So I'm talking about the very basic or the foundation regression algorithm. So this is the most important point we need to focus on this. So this is about the displaying the data when we plot a graph like using a linear regressions or any kind of the data if we are dependent and independent variable if they are numerical. So we can represent in the form of scatter plots. It's not necessarily like dependent and independent variable has to be categorical or like that. It can be the numerical also. So based on this, like we can have the numerical plot, and the scatter plot shows that the data, we can see this, which is increasing in the linear order. Similarly, like if I go for the scatter plot, like this is a kind of the data in which the scatter plot, it doesn't help in this case. So we can see this here, it's a body fat, percentage of the body fat and the chance of heart failure or the heart diseases. So in this case, the linear regression doesn't work. The kind of the data what we can see is not following the linear. So in this case, we cannot apply the linear regressions. So in this case, we need to find out like what are the kinds of the fat percentage. We need to find out the threshold. Then we have to go for the different types of regressions. That is the logistic regressions. We can go for that. So I'm specifically focusing on and linear regression. So linear regressions, which plots the linear kind of the graph, that is y is equal to mx plus c. So that's the thing, it's going to follow it. So in order to explain this, I'm going to demonstrate using the Colab. Can you see my screen, ma'am?
Ma'am, it's still in the PPT, ma'am.
Okay, okay. I think I need to share the complete one.
Yes, ma'am.
Yeah, can you see, ma'am?
Yes, ma'am. Now, perfect.
Yeah. So I'm directly demonstrating using this TensorFlow. So as I told you that the TensorFlow is an API from the Google. So where this linear regressions, which is a foundation algorithms of machine learning, will be explained with this. So this is a few data set which has been taken here, which is based on the temperature, rainfall, and humidity. So here we are going to predict about the tons of apple and orange on the particular region based on this parameters, this temperature, rainfall, and humidity. So we can consider these parameters as an input variables, are the features, and whereas my apple and orange are my targets, or in which we can call it as a dependent variable. So based on these regions, we are going to find out these are the few kinds of data sets which have been taken, and we can consider this as a training data. By using this particular training of the data, we can able to predict our model from that. So we have the linear regression model in which each target is estimated by the weighted sum of input variable. So as we know that the formula what we have is y equals to mx plus c. So if I'm talking about in the linear graph, the straight line, where the c is some constant where we can consider to be as a bias here. From this, it would be the W1, W12, and W13 are the weighted sum of an input variables, and there would be the some constant. For example, for this particular region contour, in which I'm supposed to find out the apple and orange, what are the kind of an orange or the apple which will be yield, depends upon the temperatures or the rainfall and humidity. This is how it is calculated. So this would be the temperatures, the rainfall, and the humidity. It would be multiplied by the some weights, and there would be some constants of the bias will be added. So it's actually following about your y is equal to mx plus c, which is a cumulative addition of all the features which has been present and some biases added. Now the question is that why this bias is added. So we can assume that maybe the situations like there might be the situations like the temperature, rainfall, and humidity might be the zero, but the yield of an apple should not be the non-zero or zero content should not be there. So in order to make this as to be biased, make to set so that it should not be the zero variable, there should be some non-zero content has to be present for the yield of an apple or an orange in these situations. So we are going to add a bias. So this is for the case of one, with what the data set we have. The similar thing was going to apply for the any kind of the biases based on the data set. So I'm just taken the few data sets where I'm going to perform the basic NumPy operations. And from that, I'm going to get these data set as this. But similarly, if you're taking any data sets, then definitely you can go for the pandas and NumPy. to read those data sets from CSV file or your Excel file, or even from the website, we can read that data set. In order to understand this, I'm just taking this an example of this. So this is like the graph, what we can see here. The graph, what we can see here in this case is it's a three-dimensional graph. Definitely, I not consider and it's just a pictorial representation of the what we are taken the data here. So rainfall, temperature, and are considered with an apple here. And definitely, I'm not consider and humidity as a parameter here. It's highly difficult to show about the four-dimensional graph over here. So as we can see here, as the temperature increases, so we can see this, there is a yield of apple increases, and even the rainfall increases, there is again the, according to the data, what we have is that the yield of an apple increases. But eventually it should not be the correct also, this data set, because if the temperature increases the more, and then definitely the yield also affects, then definitely the rainfall increases also, it's going to affect. But just to understand that the main focus of today's like in explaining the linear regression is about like understanding the concepts of weights and bias, how they play in making a predictions of the data. That's actually the most important part in the biases and the weights. So this is one examples to show you that. So there is one more thing, like when to adjust this weights, we have something to have a better predictions. We use this a technique and of an optimizer, in which an optimization techniques. So today I'm going to explain or talk about the gradient descent, which is a more important type of the optimizer, which is used for most of the algorithms it is. So instead of going for the traditional kind of a PPT, I'm just using this Google Collapse or any of the APIs, the Kaggle, because to understand that how exactly it works. So we are using, I hope what I'm been explaining here is that I hope everyone is understanding here. I'm just speaking from my side. Yes, ma'am.
Ma'am, it's clear to me actually, but actually the participants are muted. So kindly give
Okay.
the reaction smiley so that ma'am can understand if you're able to follow.
Yeah.
That's fine. Thank you.
Thank you so much.
Yes, ma'am.
Yeah. So yeah, regarding the system requirements, since I'm using the import that the NumPy and the TensorFlow, definitely I can just by using the single line of a code, I can use that installation process. Definitely when you're going for the systems on the system, you have to download the packages like they are the NumPy and TensorFlow. You're going to do that. So what I'm going to do here is I'm going to differentiate between the data sets as two things. One, it has an inputs and targets. So generally, even this process can be done by using the Panda, where we can slices out the different kinds of rows, number of columns, and as a separate one. So here I'm using the data set, what I have taken here to make the mathematically to explain the things. The same thing I'm using here. So as you can see this, I'm just preparing my training data, which is of two types, which is an input and targets. So I'm using the NumPy and TensorFlow. I'll just simultaneously run the things. Um, I think there is an error here. 1 second, ma'am. Just I'll see this. Uh, 1 second, I'll just go through that and I'll see that why it's not working. I was running on the collab. Just give me a second. I'm just changing with the different binders. I'll be running on the binder. Maybe that probably works. Um, so getting an error from the TensorFlow package. Let's do the quick installation for this. And it was working on there. And yeah, I'm doing that pip install also. And I'm sorry for the delay in this. Divya ma'am, for the kind sorry for
Ma'am,
the
no issues, ma'am. We all would have faced the same problem with Golab. We
yeah.
understand that.
Yeah. And I was actually even doing on the PyTorch also. That was working fine.
Okay, okay.
Yeah. Yeah. So regarding this, what I'll just explain this, and later on we can run through this codes and all. So what exactly we are doing here is after me installing the TensorFlow, we are called as an object of TF. So we are using a NumPy array. We are putting the same data here. This is for the temperature. This is for the rainfall, temperature, and humidity. And similarly, the targets, we are set it for the apple and orange. So the same data what I've taken there, the same thing we had used here. So since I want the data to be as a float type, so I'm just converting into the data type as float 32. So it's just instead of making it every point as 73.00 as a decimal number, it's better to convert by using float 32, which is very easy to do this. So in this process, what we are doing here is we are just differentiating the input and targets as two things by using NumPy array we are using in this. Similarly, the CSV file, we can use this where we can even differentiate both into two kinds. So next what we are doing here is we are converting this NumPy data into the TensorFlow. So tensor. So the tensor, which will be very useful for to convert the most of them operations it's performing on the float data type. So that's the important thing that we already converted the float 32 and we are converting this data into the tensor, convert to tensor as an inputs and the targets. So I'm using the same name here as inputs and targets to make that not to get confused. The only difference is that what we have seen here as the NumPy data as an array has been converted into the tensor. So there is not much differences in the kind, if I see about the data, but it is used for the operations of the computational operations, what we can do it, it makes easy for that. Let's see that like if it has been downloading it is, still it is collecting and downloading. That's done. Yeah, let's see this. But it is not giving an error also. Okay. I think there is a error related with this. Is it okay, ma'am? Just like because already my run outputs are here.
Yes, yes, ma'am. If the outputs are there, then that's pretty much easier for the participants to cope with.
Yes, yes, yes. And if they requires this notepad like notebook also, I can able to send it properly. So I think they
Yeah,
can.
yeah, yeah, sure. That would be more than enough, ma'am.
Okay, fine. All right. So now this is about like we differentiate as in inputs and targets, and now we can able to differentiate like what are the kinds of data type with respect to the NumPy and all. The everything is remains the same. Only difference if I see about this is about there is a representation of the comma has been replaced by dot operator. Then it's about the kind, the representations and the shapes. It's mentioning about 5 comma 2. We have the 5 rows and 2 columns, and which is about orange and apple and orange. And similarly, we have a 5 rows and 3 columns for rainfall, humidity, and for the temperature. Let's go for the linear regression model from the scratch, what exactly we consisting of. As we have seen in this example, like this is a equation which consisting of weights that's multiplied by the weights, and there is something called as a bias. So, but the data set what we have here, we have only the temperature is available here, the rainfall is there, humidity is there, and there is no as such, the bias is not available from this data set, and weight is not set, no, weight is not available. So as I mentioned that my main focus is about on the weights and the bias, how it is affects the model. So I'm going to take about the few models from the random values, which is going to initialize it. So by using the random variable from the TensorFlow model, so in which the random values are being generated. So where I'm going to mention about 2 comma 3 and again is about the 2 for the biases. Since we required the biases about B1 and B2, whereas the weight we required is about this one. Let me show about this. So if I'm talking about the weight, that would be W123, W1, W13, and that this had actually transposed it. So since I'm intention means my focus is to get about the 2 rows and that is 3 rows. We have the in this case we have a 3 rows and 2 columns. So that's why we are randomly created by using some values. So initially to set the models, we are taking from the any random value. So once we come to know about that, what exactly my loss, where my model is set. So accordingly, based on that, by trial and basis of this, I can able to set each and every weight for that weight and as well as the biases. Sometimes the weight has to be increased and decreased. So that's the thing I'm focusing on this. And we have the bias here, B1 and B2. In short, we are actually using our random value for in our case. So when I'm using the random value for biases and my weights, definitely the model won't be the good enough for that. But again, I'll just want to show you that and how we can increase this. So you can see the values here for this, the variables, what we can see here, the value is between that minus 0.49 and minus 1.26 and all. It's just a matrix which has been created for 2 rows and 3 columns, and where it has been created randomly pick the value where the mean with a normal distribution with a 0 and with a standard deviation of 1. So the random value, it can be taken from -1 to +1, or it can be taken the any range from the random value. So where we are set the mean as 0. So that's not the focus of this. The focus for us today is that how it will be producing, how it is going to affect. So similarly, you can see about the bias also, the values again, the minus 0.823 and minus 0.83. This is for the initial, for my model, this is the weight has been taken for this. So I hope I'm clear with this random value, what it has been taken here. So the mean as one, normal distribution is 0 and the standard deviation of 1. So this is what it has been created at any value from -1 and all. So this is what exactly my straight line, the y is equal to mx plus c. This is how the exactly the equation works here. So what exactly I required is I want a weight transpose of this. Because this particular row has to multiply by this column. This is what we mentioned in our formula also, that is in my beginning of the formula. So this is what we mentioned about this W11, W12 and W13 has to be multiplied. So that's the most important thing, is that we need to transpose that. Yeah. Yes. So now we have to do the transpose and then with the addition with some biases. So that would give you that prediction of that value, that the y predictions will be easily predicted. So this is a very simple formula for the model. So instead of going for directly the inbuilt models which is present in the TensorFlow, so I'm using the model as a functions where we are creating here. So what exactly here I want to do here is I want to multiply this x, which will be stored here. This ampersand symbol indicates the matrix multiplications. It's not the kind of a star we used here. So in case of TensorFlow and as well as in PyTouch, we use an ampersand here for having the matrix multiplications. And what we want to do here is we want to transpose this. So this transpose this W matrix, that's why which is using the TensorFlow. There is a function called as transpose. We are transposing the W plus we are adding the bias. So finally, the returning, it would be the return, what the function is going to return about this, the multiplication of this particular row with this one and added bias. So definitely we have the weighted value for this and it would be resulting with one single number. So when I multiply this, when I run through this, and sorry for that, like it's not coming for this, like definitely it will be represents with two things. Like if I'm seeing here, I'm giving the model and going through my inputs. So you can see my inputs, what's my input consisting of. The input is my, where I differentiated, this is my inputs. So I'm passing this as an input now. And from that input, it's going to perform an matrix multiplication because I'm using here transpose of W and B is already stored. From this, I'm going to result with this one. So what exactly I'm getting here is there is the predicted output. What I'm getting here is minus 101 and there is again it's minus 141. Then these are the for the orange and this is for the apple and orange. This is my predicted value. So once you can see this, compare with the targets. So this is my target value, which I showed in the beginning of the thing, but I'm just showing it again. This is my target value is 56. So what I am predicted from this, there is a huge variation here. So there is a huge variation differences is there because it's not a comparable. Definitely my model is not good enough to take forward for this. And definitely it is very good for us because we have just set up our model with some initial random variable of weights and as well as for the bias. So there is a difference between this, my predicted and as well as my target value. The value what I'm expecting and what I am getting here from the predictions from my model, there is a huge differences there. So that difference, we call it as a loss function. So there are different kinds of loss functions in machine learning. So I'm going to discuss about that is mean squared error function, that is a MSE. Other than that, we have a RMS, RMS Pro. So there are different advanced kind of loss functions are there. So since my working, the concept is only on the basic thing, so I'm working on the simple loss function, which is a mean squared error function. So let's see this how exactly the mean squared error function exactly works the mathematically. It will calculate the differences between the two matrices, that is your predicted and target values are being difference as calculated. So once the difference is calculated, that is going to square all the elements present in that matrix to remove the negative numbers. So once we get with the negative numbers, then what it's going to do is it's going to calculate the average of this. So that's why the term called as a mean square error. Means we are actually getting an error, we are squaring that, and we are getting a mean. So that means our mean squared error, which is an MSE. So instead of going for that already inbuilt functions, I'm just include this function for this to calculate an MSE here. So where MSE, I'm going to calculate with the two inputs I'm giving here, which is nothing but my prediction and my targets. So from this targets and predictions, what exactly it's going to do? First, it has to calculate the difference between the two one, that is T1 minus T2. After that, it has to square the thing. That is, the first of all, it has to uh, getting the sum, squaring the sum. Then it has to calculate the average. So what we can see here in this case is, we can see here is difference into difference, which is nothing but my squaring the function. Then we are using that TF dot size. So with, of course, in my cases, I know that we have only the five number of data sets are there, means values are there. But definitely when we go for the large data set, we cannot able to count it and do it. So then TF dot size will give you the exact number of elements present in that data set, number of elements present in that. So that's give me that mean square error function. So this mean square, that is MSE is a mean square error it is. So this is my function, what it has been, means we have developed that, and which is nothing but my loss. So what I'm going to do here is I'm storing in one variable since it's returning the variable. So MSE equals to predicted minus targets. So that it is going to give one single value. What exactly it's doing here? It's going to subtract the each element wise. Each element wise, it's going to perform the subtractions performing. After that, the squaring is done on each element wise. Then it calculate the average of numbers then by the formula what we are given here. So that's what we are going to get about this, an average value which is nothing but 59,592. So this is actually the value. If I'm taking the square root of this and an average, it would be there is a huge difference between, there is a huge loss is there. So we can predict that there's a loss is very much more losses there. So this indicates that the model is not good enough for that. So this is for the linear regression. Similarly, if you can go for any of the cases, the loss has to be the lower in order to have the better model. So now we have come up with the thing like we are forwarding the things now. Input is given and output is calculated, and from that we are calculated the loss. So now what? Now we have to get our weights and biases by adjusting in such a way that we have to make our loss to be reduces. So that's what we have, an answer is ready with us. That answer is like we have the losses has to be the low, and so we know it. And from that we have to reduce our thing, as I show in the initial thing of that, what is the difference between the classical and machine learning algorithm. So then that comes the role of compute gradients. So we have this place of, there's a optimizer which plays a very important role here. So again, there are different types of optimizers are there. So I'm going to explain about the gradient descent, which is a well-known optimizer technique which has been used. So in the TensorFlow, the gradients are being computed by using tf.gradient tape to record all the operations on a tape. So it is going to calculate the derivative of y with respect to the x. So similarly, when I'm giving about the gradients, it's going to calculate the derivation with respect of dy by dx. So from that, it's actually calculating the derivative of the loss functions with respect to the gradient tape block. Since we declared here as a weight as w and b, so as a tf dot variable, so automatically grade type, it's going to calculate about the gradient or the derivative of d of w and d of b with respect to that. So let's see that how we can able to calculate the gradient descent from this predicted values. So here, as I told that with tf dot gradient tape, we make a persistence true as a tf. So we are passing a model for the prediction and as well as for the loss here. By giving this, then if I'm giving this, I'm just not going to do anything here. Then we are just printing the w and as well as the uh, I'm going to uh, I'm going to give the gradient with respect to the loss with respect to the W, means with respect to the weight. So I'm interested to calculate the loss function with respect to the weight and as well as with the bias. So this is what we are going to do now. So as you can see here in this case that when I print for the weight, so this is my weight random value what we have taken here, which is 2 comma 3, where we transpose into the W transpose and we calculate our Y value, that is the Y predictions we calculated. But we are seeing here as since W it's a 2 comma 3, then we are calculating here gradient loss function with respect to the weight. So this is what the number we are getting here. That we can, as we can see this in this case, there is the value what we can see for the quadratic equation, which the loss function generally it follows the quadratic functions for the weights and bias. So our object is to set that the loss is the lowest. So similarly, when we plot this graph, this is the ideal situations I'm just showing for this, for the any kind of a gradient descent to be considered. So this is for the just one polynomial function. It's not exactly the quadratic equation I'm taking here. So if I'm taking a quadratic equation, it should have the one minimum and one maximum. Whereas in this case, we can see that there is a one slope which where we considered here. So in this case, from this, we have to adjust on my weight. This is a gradient, my gradient element, if it is a positive thing, I have to select in such a way that my weight has to increase, slightly increases. When you can see this, if it is a slightly increases, we can see that my loss is also increasing. Similarly, my weight has to be decreases, so definitely my loss function is also decreasing. So my focus is that what I want to decrease my loss function. So it's very clear that depending upon my the gradient value, which is a positive or the negative, I need to fix it. So from this value, what we calculated, as you can see this, my all values are my negative. My gradient with respect to the weight is negative. So definitely I need to reduce weight. So this is what I come to an conclusion. So increasing slightly element, then definitely there is a slight increase in my value, means change in my weight. One second. Yeah. So definitely if my gradient element is negative, so as you can see this, so in this case, it's just inverse of the thing. Once my weight is increasing towards this side, so you can see this, my loss function is decreasing here. Whereas my weight value is decreasing, I can see that my the loss is increasing here. So it's just an opposite of that. So we are very much each weight has to be, and definitely my API or the TensorFlow or the PyTorch, so they will going to take care about each and everything, whether the weight has to be increases or decreases. So this is, I'm explaining about the what exactly the theoretical or the mathematically, I'm not exactly entering into the mathematical of this. So this is about like how exactly it's working on the gradient element positive or increases. So the increasing or decreasing of the loss by change in the weight is proportional to the gradient of the loss with respect to that element. So this forms our this optimizations algorithms. So generally the optimization algorithm, what I told about that is a gradient descent, which is definitely going to increase our model. So we are not going to do that like well, for which value it has to increase and decreases. For each every weight of a gradient, it is going to take care that which has to increase or decrease by adjusting this weight. So these are the few steps of the algorithms which works on the gradient descent algorithms works. First, it will prediction, that is generates the predictions, calculate the loss, the compute the gradients with respect to weights and biases, because this plays a very important case in our case. Definitely, if I'm going for any of the parameters depending upon the data sets, then definitely the weights and biases in case of a linear regression, it plays a very important. Coming back to in our case of maths, it's about the dy by dx, the x is a component, but here you should be stick to that loss, derivative of a loss with respect to the weight and derivative of loss with respect to the bias. So adjust the weight by subtracting the small quantity proportional to the gradient. So this is generally done in this case. It will be after computing the gradients. So what is the next thing is that very small proportions we are going to subtract it. Since we have seen here, since my gradient is positive or the negative, we are going to assign in such a way that I'm going to consider the adjust weight by using the negative value, definitely which can be considered for the slightly increasing also. The main intention is to reduce the loss. So from this, we are calculate the, again we are calculated from this one now, the tensor what we are calculate the loss here. So coming back to this, like what we have calculated in the previous and now, so you can just see this here. Yeah. So for this, each and every case, the loss functions what we had, uh, I think we're not printed here. Yeah, even it is 59,598 are they? And whereas in this case, I think I need to run this again. That would, but it will give the error. Yeah. So after this, after applying this, this is what we just try to print that. And by passing the values here, we can see here it has been, the loss has been pretty much reduces from the 56,000 to 50,000. This is in the one epoch of running. So when it goes to the multiple epochs, these values is been keep on reducing its value. So this is just to show you that like, yeah, let me explain this like weight and again, we are going for this. Since we use as a gradient true, the gradient doesn't we are make it as a true in this case, that is persistency we are true, what is we are given here, persistent true. So automatically this weight and biases are updated. So from this, we can calculate the loss. So now I'm again calculating the loss by using this, where I'd use this function here. I adjusted this. Once I run this calculation, this is not the function here. This is itself is a program set where I'm using the gradient descent calculation. And once the weight is automatically updated from this. So the new weight we can see here, this is my new weight. Let's compare with the previous weight what we had here. So this is what the weight we had of minus 0.491 and minus 1.20. Compared to this is the when updated one, this is my new weight. So these weights are automatically gets updated in the TensorFlow by using this gradient tape which persistence we are made it as a true. So for that, what are the calculations we've done behind here? So the automatically this gets updated. So once this weight and bias are updated now, once again I calculated my predictions and loss function. So this loss functions now reduced considerably for one epoch. Once it goes to the multiple epochs, generally the iterary epoch is nothing but an iterations. So each time the process of reducing the weight will be increasing or decreasing of weight and biases, then definitely the multiple times then the, the loss functions will, the value will be reduces. Once I run this, I repeated this process for 100 times. So what I can see here is my loss has been reduces to uh, 219 here. So now when I predict this value, so what we can see here in this case, it would be they come to the prediction value is 62 and which is actual my target is 56. So once the 73, which is the 70 and 100, it's 101. So by comparing the both the things, it's quite close to the target it is. So even more the results can be increased even if it increases an epochs to the higher version, maybe the more number of more than hundreds and all. So more number of iteration if it is passes through it, then it can give you the better quality that is an efficiency of a model will be increases more. So we can expect that the loss value will be low as we can increases a more number of epochs. So this is about like from the basics, how the mathematically whether using the Python functions and from the TensorFlow without using an API of TensorFlow, this is how it has been implemented. But unfortunately, by some problem, I was running on my collab when I'm going here. I'm so sorry for that. Like I could not able to run and show the thing. And this is with respect to the basic fundamental and calculation. Next, I just want to show you that how exactly all these operations which can be performed by using a TensorFlow or the Keras, which are the built-ins, where we are not going to calculate and see the thing. The best part of this collab or the thing, as you all know, that like we can able to visualize the things by line and find out what exactly happening on the each singular line of the code. If you are understand with this concepts, can I proceed with the TensorFlow of which is having a built-in?
Participants, you may please use the reactions so that ma'am will understand. Yes, ma'am, I think they are pretty much clear with that. We see that smileys.
Okay. Thank you, ma'am. Thank you so much. Yeah. Okay, so this is about the linear regressions, what exactly the fundamental it is. But if you same thing, if you apply for the any of the other algorithms or the any different types of an algorithms we have, then instead of going for the direct API, it's always try to understand with the simple data sets, maybe by the NumPy, creating our own data sets that will give a very clarity for that, what exactly we are doing it. So till now we are done with so many kinds of the codes which we are being used for training, epochs, and for creating the model. But TensorFlow, which has made very simple, if I'm using by the Keras inbuilts are there. So what you can see this, we have the inputs and as well as the targets, what we are done in this, the same thing for that in the implementation. And we are using here the little bit data set. What I'm using here is a different data sets using here this time, little bit data sets like 15 examples have been used for this case. Like we have been separated there. In that case, I'd use only the one particular things. Here, the data set is quite bigger one because generally when we go for machine learning, definitely deep learning algorithms, it requires a huge data set. So that cannot be applied. To make this TensorFlow, the APIs to work, I've taken a few data sets of random values itself again to make it to understand here. Again, we differentiated into the two types, that is input and targets here. So from this inputs and targets, we are actually making this slice and creating as a data sets. So what exactly we are doing here is we are rows from the inputs and targets as a tuples. We are treating as a tuples. So because API requires and data sets rather than by having a different types of the things, because it's going to differentiate about the training data. It's going to get from the training data set it is. So then I'm going to mention this as a size of at a size, how much size of the data has to be there. I'm mentioning the data size as a batch size as 5. Where at a instance of the 5 data set which has been accessible in one separate set. The we had given the same kind of a data batch we had been using here. So next, that is very clear here. So I'm setting into the data set where I'm combining both the inputs and targets. Then I'm deciding my batch size where I'm giving it as a 5 here. After this, what I'm doing here is I'm just creating this data set into the batch data set. And now it has been accessible to look like this. I'm just printing this now from data set as a separate one, X and Y, to make sure that like what exactly we are here. So it, as you can see here, it has been differentiating in the batch size of 5. So even though we have the 15 data sets for everything, like this is for one data set from here to here, it has been differentiated one, and another one it is input and training. So sorry, input and target, it has been differentiate into 5 data sets. So this is how I can show you about like how exactly the batch size matters a lot in this case. So next is about the creating the models here. So in the previous examples of the models, we are generally try to create the models, try to create the loss functions. What are the loss function meant for? It's nothing but the prediction minus target, like what is my targets and predictions and squaring of that. That's what we have done it. So whereas in this case, when I'm using the models, it's pretty very simple here. Just I'm using this as from the TensorFlow, I'm using the Keras where I'm using the models of sequential, where I'm creating and layers of in which it's the size of the model, like how what would be the targets I'm getting and what would be the inputs I'm been providing. So that I'm mentioning here. So this is quite simple here, which is already present there. Then I'm just going to check that weights here. So whereas in previous case, we used to set the weights, we used to calculate it, right? So here by using this automatically, it's taking this as a by default weight. This is the where we set it as a weights, and this is the case where it is taking by its own value from the based on the model, the data it is generates exactly the what we are taken there. So now if I go for the inputs, if I'm pausing this, yeah. So then if I'm giving an inputs and predictions, you can see this. This is what my prediction model works. So this is exactly almost getting what I'm getting here, but still we calculate an error functions. So once we calculate an error function, so unfortunately I could not show the proper value for this. Yes, but I can just, because if I run this, it will give me the error because I did not run with the previous one. So definitely the loss would be the very much low. So compare it, definitely there would be the loss functions when you compare this by seeing this itself, this predicted with the target value is this one my, we can see this is my target. So there is 56, 70, and then again there is 81 and 01. So compared to that, there is a slight variation, which is not exactly I'm not getting in this. It means that, see, since I remember this 56, there is a 37, and since it's an 80, there is a variations. And as you can see this, there is a negative number indication. It's very much clear that there is a loss present here. So what is the next step we need to do here is we need to reduce the loss. So the loss has to be reduced by using an optimizers. So here I'm using the stochastic gradient, that is a kind of a gradient descent algorithms here, where I'm using the learning rate, what I'd used there, that is 1 into 10 raised to power minus 5. It is my learning rate was a small a small step where we are increasing here for the small step instead of giving for the bigger one. So once we're done with this, so for this optimizers, then we optimize my data is been it's run with the thing like optimizing. It will updates the weight and as well as the bias. So the same step here also we are done here. But in order to train the model, so instead of writing it again and again, I declared a function called as fit. So where I'm passing here as number of epochs, the how many times it has to pass through it. The model I'm giving here, the loss functions, what we calculated there, then its optimizer and training data set. By passing this, otherwise it's not required that even we can go through that part, but this makes very simple that if I create a functions as a fit, it will give you the very simple way of calculating. That's the reason. So once I'm done with this, as you can see this 100 times, like you can see this at the beginning of the in the 10th, we have 191 is the loss functions. When it goes through for the 100 epochs, we can see that there is a loss has been reduced to the 47. So once we predict this model now, we can see this now. There is the number what we can see here. It was a 56 somewhat there. So yeah, so you can see this also. This is a target model. This is quite near to the target and predictions are quite matching. And definitely then you can calculate the efficiency of the model by using the efficiency, the how much efficient the model is that. So that also you can calculate it. But I'm just showing by visualization since my data set is too low. I'm just comparing with these values itself. So here, yes, after what once I want to tell you is that like by comparing this model by giving the rainfall temperature and humidity, we can able to calculate like what would be the region wise, we can able to calculate what would be the yield of apple and orange in terms of tons. So it would be very easy for like based on we have some rainfall temperature and humidity from the previous analysis, it would be very much useful for the farmer kind of the point like to have like where they can and which kind of the crop they can grow for that. Uh, I think I've completed with the sessions. Like if you have any doubts, I'm like open to answer the question.
Okay, ma'am. Thank you so much. I'll just unmute all participants so that they can ask if they have any queries.
Yes, ma'am.
Okay, so participants, it's your turn now. So if you have any queries, you can please unmute and ask the query.